From previous session, we saw what advanced features we can implement using Golang. As part of this session, we will learn about interfaces and how to use interfaces and advantages of interfaces as part of advanced Go features. Let's talk about Golang interfaces and their usage as part of this session. In the Go programming language, an interface is a type that specifies a set of methods that a concrete type must implement in order to be considered an interface of that interface, instant of that interface. Interfaces provide a way to define a contract between different parts of a program, allowing them to communicate and work together in a flexible and decoupled way. Here are some common use cases of interfaces in Go. Abstraction and decoupling. Interfaces allow you to define abstract types that can be implemented by different concrete types without requiring those types to be tightly coupled to each other. This promotes modular, reusable code that is easier to reason about and maintain. Polymorphism. By defining a common interface that multiple types implement, you can write code that can work with any of these types without knowing their specific implementation details. This makes it easier to write generic code that can handle a variety of inputs and outputs. Mocking and testing. Interfaces can be used to define mock objects that simulate the behavior of real objects during testing, allowing you to isolate and test individual parts of your code in a controlled environment. Extensibility. Interfaces provide a way to extend the behavior of a type without modifying its implementation. By defining a new interface that extends an existing interface, you can add new methods that build on top of the existing behavior without breaking the existing code. Dependency injection. Interfaces can be used to inject dependencies into functions or objects, allowing you to swap out implementation at runtime. This can be useful for testing or for creating a pluggable architectures where different modules can be swapped in and out without requiring changes to the core code. So interfaces are a powerful Go tool that enables flexible, decoupled and extensible code. By using interfaces to define contracts between different parts of your program, you can create modular, maintainable and scalable code that is easy to reason about the test. Let us talk about the programming part, how we can depend. So initially we discussed about abstraction. In this case here, I just created one interface called animal with the two functions inside it, like name and speak. Okay. So this interface we are overriding here for the dog. So dog function for name, it is a dog and it will speak like a wow, like that. Cat name is cat and it speaks like a meow, right? So now what we are doing is in the main function we are creating array of animals. That animals actually includes dog and cat, right? We're trying to print what values it will be printing. Basically we are using animal instance to call the right object, like a what kind of object we have created during the initialization of the array. For example here, just try to execute this. Yeah. So if you see here in the for loop, first we are created object of dog, object of cat in the array of interfaces animal. So we're trying to print animal name and it's what it speaks, right? Right. So next thing what we talk about here is like polymorphism, right? Let us see how the polymorphism works here. So here if you see this code, so we have created a one interface called shape and square object. Square object actually having length and length, right? Length is enough to calculate the area, length into length, right? So that's what here we are calculating area. And circle will be like a pi r square, right? Circle area will be like you need to have radius and its pi value is actually 3.14 and radius square is radius into radius. So similarly here we are trying to create the shape interface array, actually slice with the, we are just initializing with the square and circle objects and we're trying to calculate the array of this one. Let us see like how it works. You know all this command how to run the program. So if you see this length is like 5 it will be calculated length into length 5 into 5, that is 25. For the square and circle, pi value is 3.14 and 3. This is a 9 into 3. It's coming like a 28.25 or 26 approximately, right? Okay. So now, like how to mocking and testing. This is about the polymorphism. Let us talk about mocking and testing here. So here what I did is I just wrote one interface with a database and which has a query which will take the string and it will return the array of strings and then error, right? Okay. So now what we're going to get data from the database. We are trying to pass the database interface and we are trying to return the query results and these things. This is the just kind of structures here, structures and the function. So how to actually mark this test cases for this particular files, this particular code. So if you see here, we wrote one function called get data from database, right? In the test case, what we wrote, test get data from the database. So we already discussed about this testing is a package. Through that package, actually, we are trying to implement the test related stuff here, like test errors, test pass, success fails, all of those kind of things. So if you observe here, actually, we did a mock for the database, right? And also we are mocking the query method. But if you see here, query method is nothing. We are not implemented anything, but here we are mocking that one, right? This we are mocking. And what exactly this query is trying to get these values basically. So whenever we are trying to call this method, we are just trying to mock db. Basically we are creating a new mock database, that is this one. This mock db is created and mock results we have just trying to create like a user 1, user 2, user 3. During whenever this mock db dot on query is called with the select star from users, we are trying to return mock results is nothing but a user 1, user 2, user 3 and the errors will be nil. This is actually completely mocking. Exact the query method is actually we are making it as a mock here, right? Now when we get data from the database db, this basically get the results of whatever we are returning here. This function, this one actually calls this method database, and this method basically calls the whatever the mock function we have done here. So result returning will be like users and then error will be nil. Okay, so this reflect, using reflect namespace package, we are trying to compare with the result, whatever result we got here, and mock result, both are same. Let us run this test case and see like what happens. We can do this cd, right? This is actually pausing. That is one way, or you can test here also. Just click on test. This will be already running and it is executed like that. Okay, let's move on to other thing. This is about mocking and the testing. Let's check about extensibility. Okay, so if you see this extensibility, so here what we did is we have written one interface called vehicle, and in this interface we have actually drive, right? That's it. So what we can do is we can implement this particular vehicle interface for car, truck, and so on, whatever you want. But when you are going to implement this interface, that vehicle interface, we are just returning the driving model, driving actually who manufactured and what is the model of that one for the car and also for the drive. Right, this is how actually the vehicle interface can be extended to make other functionality without changing the base interface, basically extending that, right? So here if you see that vehicles, we have created the slices of car manufacturer and truck. We're trying to print this drive type basically, right? Let us see. So CD extensibility, I will share these code files, don't worry about that. Yeah, if you see that we are trying to print driving a Toyota and Carmi and driving a Ford and F1 150, that is the model, right? That is how actually we can use the extensibility. And the last one is actually kind of dependence injection. We already spoke about that. Injection is like interfaces can be used to inject dependencies into the functions or object, allowing you to swap out implementation at runtime. This can be useful for testing or for creating a pluggable architecture where different modules can be swapped in and out without requiring the changes on the core modules basically. Let us see that how we have implemented the dependence injection. Okay, so if you see here dependence injection, we have created one fancy printer, okay, and fancy printer of type struct. So we can just it just actually have in the message basically, right? So that is one such structure. And when you are going to print this fancy, when we are going to override the interface of this pointer, basically this should be moved up, right? Okay, this printer is the interface. Basically we are overriding this printer interface in the fancy printer. In the fancy printer we are just trying to print whatever message we have in the fancy printer object. Similarly, we are trying to implement the printer interface using the message printer, which also has the same message, and this trying to print the just a message. Okay, so out of the context actually we have a other structure called a greeter, which has the printer object, actually printer object of printer interface, right? Printer interface, whenever we are going to greet it, whatever the printer, either fancy printer or message printer, whatever the object it holds, that will be printed, that particular message will be printed here. Let us see how to create a fancy printer. Fancy printer you can create by passing message, right? And you can create the greeter object by passing the reference of this particular fancy printer to the printer of member variable of the greeter struct actually. Okay, and then what we are doing, we are trying to print the greet, what actually it is printing. In this case actually it will print the hello world. Similarly, what we are doing is in the message printer we are trying to create object with hello world message printer, some change. Now the same greeter object we are trying to create the greeter, and we are initializing with the message printer. So in this case actually hello message printer should be printed, right? Let us see like how it looks like the dependency injection, right? So if I run this one, this particular thing, see if you observe that hello world is printed during the fancy printer object is created during the greet function, and next time I'm injecting the message printer to the greeter object, so that will be actually printed later point of it. So these are the like interfaces uses in Golang, and with examples.